Hello. We're going to work on a problem that says, researchers studying acid rain measured the acidity of precipitation in Colorado wilderness for 150 consecutive weeks. Acidity is measured by pH. Lower pH shows values higher acidity. The acid rain researchers observed a linear pattern over time, and here's what they reported. So, we are given this linear regression, pH equals 5.43 minus 0.0053 weeks. Now, with every word problem, step one, the most important problem, is we need to label what is our input, our x, also known as our explanatory, and what is our output, our y, our response. Very, very important. Everything's going to go back to this. So, looking at this problem, we're going to realize that our input is weeks. Our input is weeks. Our output is pH. Let's talk about why. A couple of different reasons why. Number one, we're saying weeks, what week it is, explains what the pH level will be. Reason number one. Reason number two, if we look at the equation, we also have some clues. You probably remember y equals mx plus b, y equals y, pH, mx, mx plus b. So two really strong reasons why weeks would be our input, our explanatory, and output response would be pH. So the first question is, we're going to graph it. Now, this may seem a little awkward to graph because we're not given the data. Normally, you're given the data and you're able to figure out what the lowest value is, go a little bit before, what the highest value is, go a little bit afterwards. Same for the y-axis. Here, we have to kind of look for some clues. So the information they give us for weeks is that it was a 150-week study. Therefore, we'll start our x-axis, which is weeks, starting at 0 and going to 150. Then we need to decide what our scale should be. So an appropriate scale, we don't want to count by ones, probably don't want to count by hundreds, won't work. So let's go with 25. 25, 50, 75, 100, 125, and 150. Now we need to figure out an appropriate scale for our y-axis, which will be pH. So for this, we're going to go ahead and look at the actual equation itself. And if we understand how it works, for example, y equals mx plus b, m being slope, and b being the y-intercept, our slope is negative 0.0053, and our y-intercept is 5.43. So looks like the graph will start at 5.43. So an appropriate scale, maybe around 6, but does it go up or does it go down? That's when we're going to look at slope. We notice that the line goes down because the slope is negative. So we'll try a scale going up to 6 and let's say down to 0, counting by ones. Okay, so for this example, we're going to go ahead and graph it in the calculator, but we already know starts at 5.43 and goes downward. But we'll show you how to do this in the calculator as well. But very important, input, output, scale. This shows we understand the problem. So now we're going to use the calculator. So first thing we're going to do is we're going to go to our y equals. So we press y equals. And we're going to insert our equation. The equation is 5.43 minus 0.0053x. Now I'm going to point out, make sure when you check your calculator, there's nothing else in y2 and y3, y4, all the way down. Also double check that your plot 1, plot 2, plot 3, that they're unhighlighted. If they're highlighted, go up to it, push enter to unhighlight. So again, we want our plots to be off, and we put our equation in y1. Now if I hit graph at this point, we wouldn't really see anything. And the reason is we have to make sure we have the correct window. This is why we did it first. So then we're going to press window. And our x minimum would be 0. Enter. X maximum, 150. Enter. X scale, we counted by 25s. Enter. Y minimum, 0, our lowest Y. Enter. Y maximum, 6. Enter. And our scale by 1. Enter. Then if we press graph, we will see our line starting at 5.43 and going downward. Thank you.